And it looks like it's recording. If you have a book, you open it to page 10, 1.1, exercises 1.1. If you don't have a book, there's a little paper there on the desk for you to look at. And if you got my email, did all of you get my email? What, about 10 days ago? I just couldn't wait for the semester to start, and I had to send you. They go, what's he doing sending emails out that early? I just like this stuff. I like to think about doing it. And so after you've read that email and you've done the stuff, read the syllabus and read what it says, I mean, it's kind of strange, isn't it? It says syllabus, but it's just a paragraph that I've written to you about the class. And then to read the syllabus, you have to go to Files and click on Syllabus. And you go why? You go, I say, I don't know why. That's just the way it is. So once you've done that, send me an email and tell me you've done it, please. And in the meantime, let's get cracking on 1.1. Oh, and you do the odd ones, right? Because they have the answers in the back. I mean, the most frustrating thing in life is to work a math problem and then wonder, did I get it right? And then have to wait 3 days or 4 days or a week till someone grades it and gives it back to you. So after you've worked the problems, you just turn to the back to check to see if you got it right. If you missed it, just check it wrong. I mean, it's no big deal. Just say, missed that one, and then go on and keep working. And then after you finished, come back and look at that one you missed and say, can I figure out why I missed it? And if you can't figure out why you missed it, then I'm here at 7:30 every Monday, Wednesday, and Friday. You can come early to class and say, hey, I couldn't figure this one out. I didn't get the answer. They have in the answer book. Can you help me? And I'll walk you right through it here in class. We'll just talk about it. And if after class today, something happened in here, they say, I didn't quite catch that because you move awful fast. And I said, well, this class ends at 8:50, and that means your next class doesn't start till 9:30. So we plan it this way, so you have 30 minutes to stay here and get questions answered and get some individual help. Is that cool or what? And you say, why do you do that? Because I love math, that's why. And I like to help people learn it. So you do the odd ones, and I gave you real detailed instructions on how to do your homework. I mean, do you understand why I can't just let you turn in a sheet of paper with answers on it? I wouldn't know whether you actually did it or just went to the answer book and copied them down. So you have to talk to me. You have to write little sentences on your homework telling me what you're doing or how you came to derive your answer. And sometimes you'll say, I don't know exactly what I did, but I got the right answer. Because sometimes you can actually do math in your head and figure things out, but you're not sure what you did to figure it out. And that's okay. You don't have to make sense out of everything you're doing mathematically. Or you can say, I just watched what you did in class and I don't understand it, but I did what you did and it worked. And there you go. See, I mean, so just let me know, unless you're writing everything out and showing me all the work you're doing. And it tells you that on the Canvas. So go to Canvas and read that information and then send me an email. So what we're going to do in class today is we're going to walk through you do the odd ones, so we're going to do the even ones in class. So problem number 2 says, what do the letters RSTUV stand for? Now see, if you don't have a book, there's no way you can figure that out. Those who have a book, it's on page 3. And what's it say? What do the letters RSTUV stand for? You don't want to tell me? Well, yes.
Read, select, think, use, and verify.
There you go. That's what you put down. And you say, where did you find that answer? From page 3 in the textbook. I looked it up. Number 4, question number 4. What is web query? Now, all of you can answer that from just looking at the little sheet that's on your page there in front of you. What is web query? Or look at page 10. Page 10. Look at page 10 and tell me what web query is.
It's a research service.
There, right there. Thank you very much. See, this is not rocket science. We're not flying to Mars or something. We're just reading math and doing it. And it's right there. It says web query is a research service. Okay? Now, how many membership plans are available in web query for a customer?
3.
Everybody see where the number 3 comes from? Go 1, 2, 3. You can count. Good. We're on the right track here. Number 6. If you're in the light use plan and you make 15 transactions in a given month, what is your total cost for the month? Which plan?
Light use.
And what does light use cost? What? $1.95 plus what?
15 cents.
Plus 15 cents times what?
5.
What?
5. Because they get 10 free.
Because you made 15 transactions, so it's times 5. Why times 5?
Because
What did it say? On the light use plan, you get 10 free inquiries. So that would be what? 15 minus 10. See how I'm putting the stuff up here where I'm doing to show you where I'm getting my answers? So what's 5 times 15 cents? See how I'm showing my work? All right. So what is this? So what's the answer to question number 6? What's the answer to, is that the one we just worked? What's the answer? Question 6. It says, if you're in the light use plan and you make 15 transactions in a given month, what is your total cost for the month? And the answer is? What? $2. We're talking about real money here, folks. $2.70. Okay? See what I mean by showing your work? You go, that looks messy. Thank you. Math is messy. For all those teachers you had in the world who said, I don't want to see any messy papers. I want nice, clean papers. Send them an email and say, shame on you. In math class, the messier the better. Because here's why. If I'm doing all this and I look in the back and check my answer and it's wrong, what can I do? I can walk back through here and see where I made my mistake. You go, how could you make a mistake doing simple arithmetic? Depravity. You haven't studied that yet? You'll get to that in some of your theology classes. Total depravity. You know what total depravity means? It means even our math capacities have been affected by sin, by the fall of man in the Garden of Eden. When they ate that apple, they messed up everything. Even our ability to do math accurately. Even though we know what we're doing. You didn't know that? You just thought there was something wrong with you mathematically? No, we just all make mistakes. Number 8. What's the maximum number of calls you can make in the occasional plan and come out spending less than in the light use plan? And now all of a sudden, we start out easy, then we start getting complicated. So watch what we're going to do here to work this problem. Read it again. What's the maximum number of calls you can make in the occasional plan? Maximum number of calls in the occasional plan, and come out spending less than or equal to the light use plan. What's the occasional plan?
20 cents per transaction.
20 times n, the number of calls I make, right? What's the light use plan? Tell me.
25 plus 15.
Times how much? Say, what are you doing? $1.95, isn't it? Plus the total number of calls minus how many? I get 10 free calls,
Yeah.
and then I take the total calls minus 10 times what?
15.
15. Everybody follow that? I mean, we can do it a couple of ways here. Everybody see what's going on? You go, no, what I just saw is an algebraic equation, or I just saw a mathematical equation, and I can't do that. Yes, you can. You just don't know you can, or you've forgotten that you can do it. And it's not something you do every day. What's 15 times both of those numbers? It's the parentheses times 15. That would be $1.95 plus 15n minus
150.
what?
150.
150. And let's just change these all to cents. Can we do that? Okay. And then this has to be less than or equal to what? 20n. Everybody see what's going on? So now I have 20n over here, 15n over here. If I subtract 15n from both sides, isn't this cool stuff? What do I get? 5n is less than or equal to plus 195 minus 150.
45.
Divide by 5. Divide by 5. So n is less than or equal to 9. You like that? Now, if you don't like doing this, if you go, I look at stuff like this and I just get a big knot in my stomach and it really frustrates me. I'm saying, okay, lighten up. You know what you can do? You can take this original equation, and this is pretty cool stuff. You can put 1 in here and see what you get for an answer. Then you put 2 in here and see what you get for an answer. And you put 3 in here. See what I'm doing? You just keep putting numbers in and working your way up. And guess what you'll eventually find? That 9 is the magic number. Once you go to 10, at 10, this is $2, and this is at 10 is $1.95. You follow me? That's a marvelous problem-solving skill called trial and error. It's published in books if you've never learned that anywhere in life. Number 10. No, we better keep going, because if we don't, we'll run out of time. Inductive reasoning. In problems 11 through 20, identify the pattern and find the next 3 terms. Okay, let's erase this. And which one are we working? 12. 2, 5, 10, and 17. 2, 5, 10, 17. And then it's got 3 little blanks, right? Because they want me to find the next 3 terms. But what did it say to do in the instructions? Identify the pattern. Identify the pattern. How do I get from 2 to 5?
3.
Add 3. How do I get from 5 to 10? Add 5. Everybody follow that? How do I get from 10 to 17? Add 7. What would I do next? Does anyone see a pattern here? Whoa, do you see a pattern? What's the next one? Add what?
9.
To get from here to here, you add 9. So what's 17 plus 9?
26.
Oh, man. And then to get from here to here, you add...
11.
Is this cool stuff? And what's 26 and 11?
37.
And then you get from here to here, you add what? 7, 9, 11.
13.
What?
13.
13. Everybody follow? You see what happens is you don't find the answer, you find the pattern, then you do the arithmetic to find the answer. And the way you find the pattern is you say, how do I get from here to here? How do I get from here to here? How do I get from here to here? Has anyone taught you that before anywhere? Okay. Okay, 2, 3, 4, 5. Well, then this ought to be old stuff for some of you and fun for the rest of you. Let's go to number 14. Oh, what, we didn't put that up here, did we? 37 and 13 is what? Now, do you see how when I'm writing these down, see how I'm showing my work? And you see how if I check my answer and it wasn't 26, 37, 50, I'd look to see and say, oh, I made a mistake in arithmetic. Okay? So now let's look at number 14. And see, that's the key right there. Identify the pattern. Identify the pattern. Identify the pattern. Whenever you see this stuff, 3, and 3 with a what? A 4 up here, and then 3 with a, whoa, an 8 up here. And then 1, 2, 3. Does everyone know what we're doing here? Does everyone know what this number, can you read this number?
3 squared.
3 squared. This is 3 to the first power. This is 3 to the second power. This is 3 to the fourth power. This is 3 to the eighth power. So do you see the pattern? One to 2 times 2. 2 to 4 times 2. 4 to 8 times 2. So now I'm going to have 3 to the what?
The 16th.
To the 16th. And then I'm going to have 3 to the 32nd. And then I'm going to have 3 to the 64th. And just for fun, if you want to figure that out, you say, who would do that for fun? Okay, put in your search engine, Calculator Pro. Click on Math, then go down and click on Math, and then click on Exponent. And then it'll tell you to put in the base, and you type in 3, and then it says put in the exponent, you type in 64, hit the button, and it prints the number out for you. It's about this long. Do all of us know how to use the internet to our advantage in this day and age? But just leave it like that for the sake of this problem. Number 18. What we got here? Number 18 says 1 over 14. Then 1 over 9. Then 1 over 12. Then 1 over, where'd it go? 7. Then 1 over 10. And then 3. How did I get from 14 to 9? Minus 5. How did I get from 9 to 12?
Plus 3.
Plus 3. How did I get from 12 to 7?
Minus 5.
Minus 5. How did I get from 7 to 10?
Plus 3.
What do I do next?
Subtract 5.
What do I do? Minus 5, plus 3, minus 5, plus 3. Now what? You see the pattern? What is it? Minus 5. So what's 10 minus 5? 5. And with the 1 on top. And then what's the next one? Plus 3. So what's 5 plus 3?
8.
8 with the 1 on top. And then what's the next one? Eight minus 5. There you go. Follow what's going on?
Plus.
Okay. Can you do all these now? Oh, let's do number 20. Do we have time for that? Yeah, I think we have time for that. I have to be careful. I like this stuff so much, I get busy doing them. I think I've done enough for you, but I just want to do one more for fun. 6, 1, 9. Where'd it go? 5, 12, 9, 15. 5, 12, 9, 15. I copy it down right? Now you see, if I copy it down wrong, I'm going to miss it. How do I get from 6 to 1?
Minus 5.
Minus 5. How do I get from 1 to 9?
Plus 8.
Plus 8. How do I get from 9 to 5?
Minus 4.
How do I get from 5 to 12?
Plus 7.
How do I get from 12 to 19?
Minus 3.
Or 12 to 9, I'm sorry. Minus 3. How do I get from 9 to 15?
Plus 6.
Plus 6. You see the pattern? I'm going minus 5, then plus 8, minus 4, then minus 3. So now I go what? Minus 2. What's 15 minus 2?
13.
13. And then what do I do next? Get from here to here? Plus 8, plus 7, plus 6, plus 5. Everybody follow that? 18. And then what's the next one? Minus 3, minus 2, minus 1. Oh, there you go. How much fun is that? Number 22. The first 10 triangular numbers are 1, 3, 6, 10, 15, 21, 28, 36, 45, and 55. Put those up here. Where'd they go? 1, 3, 6, 10, 15? And then what? 21, 28, 36? Then what after 36? 45 and 55. How do I get from 1 to 3?
2.
From 3 to 6? From 6 to 10? You see the pattern? So now, could you use that pattern to answer a bunch of questions here? Like question A, what's the difference between adjacent triangular numbers? Then find the sum between adjacent. Find the sum between adjacent triangular numbers. For example, 1 and 3. What's 1 and 3? 1 and 3 add up to what? 1 plus 3 is 4. 3 plus 6 is 9. Is that what they're saying to do? Six plus 10 is 16. 10 plus 15 is 25. Does anyone see something magic about these numbers? Let's do another one. 15 plus 21 is 36. 21 plus 28 is 49. Have you seen a pattern now? 49 is 9 squared. This is 6 squared. This is 5. Sorry. I made a mistake. Blame Adam for it. No, just take responsibility, Tom. It's your fault. You just saw the 9, put down a 9. 5, 7, 6, 5. 4 squared. 3. 3 to the second, 2 to the second. Is that pretty cool stuff? That's why they're called triangular numbers. No, so can you see where you can use this information to keep extending this out and finding more numbers? Well, good for you. Let's turn over here to, let's see, number 26. The figures below show the number of line segments that can be drawn between 2 points and between 3, 4, and 5 non-collinear points. How many lines can be drawn between 6 non-collinear points? Between 2 points, I have 1 line. Between 3 points, I have 2 lines, right? Between 4 points, I have, let's see, 1, 2, 3, 4, 5, 6 lines. No, this is between 3 points, I have 1, 2, 3 lines. So 1, 2, 3, 4, 5. What would I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can draw 10 lines. You follow me? Everybody see what's happening? So how did I get from 1 to 3? Add 2, right? How did I get from 3 to 6? Add 3. How did I get from 6 to 10? So when there's 6 dots, so this is 2, this is 3, this is 4, this is 5. When there's 6 dots, what will it be? Add what?
Add 5.
15. And when it's 7 dots, I'll add
6.
what to 15? 2, 3, 4, 5, 6. Everybody see the pattern? 21. You follow what's going on? And you see how I show my work here? See what I'm doing? I just put this stuff down. I don't try to do it in my head. I put it down on paper so I can look and see what's going on. Number 34. Consider the pattern. 1 is 1 squared. 1 plus 3 is 2 squared. 1 plus 3 plus 5 is 3 squared. 1 plus 3 plus 5 plus 7 is 4 squared. So what's 1 plus 3 plus 5 plus 7 plus 9?
5 squared.
Yeah, I mean, you understand how once you start doing some of these, your mind just starts thinking in that routine. So then you just find the next 3 lines. Number 38. There's a pattern relating to the length of the foot and the shoe size. For men, the pattern is a 9-inch foot is a size 5, a 10-inch foot is a size 8, an 11-inch foot is a size 11. You see the pattern? Foot size, shoe size. When your foot size is what? 9 inches. Your shoe size is 5. When your foot size is, where'd it go? 10 inches. Your shoe size is what?
8.
8. Why? You know, why do we keep asking why about everything? That's just the way people make shoes. Some cobbler years ago made this up so nobody could figure out what he was doing. Then he had his own little secret guild going, and everybody was dependent on him and his friends who he taught his secrets to. If you're 11-inch foot, you have what size? Size 11. If you have a 12-inch foot, they don't tell you. So now what? How do I get from 5 to 8? This is getting monotonous, isn't it? How do I get from 8 to 11? You understand when you look at these? It's just like, okay, think about this. You say, you just keep starting saying, what do you add? What do you add? Well, there's only 4 operations in math. If you're going to do math if you're going to crunch numbers with math, what are the 4 basic operations?
Add, subtract.
Multiply, divide. So which one would I like to try first?
Add.
Add. If add doesn't work, then what am I going to do?
Subtract.
Subtract. If subtract doesn't work and add doesn't work, I'm down to multiply or divide. But you understand? I start working with the easy ones, and what have we discovered by starting with the easy ones? Add and subtract. We're finding most of what's going on. Well, we did a multiplication thing, didn't we? Haven't done any division. Did we do some division? No, maybe we did, and I forgot about it. Because, you know, see, here's why. Really, you know what all multiplication is? Multiplication is just fast addition. Like 6 times 7 is what? I don't know.
42.
Oh, 42. You memorized your multiplication facts. The rest of you didn't. Say, I don't have to. I got a calculator. Yeah, well, when your calculator fails, you're in trouble. No, you're not. You just write 6 down, 6, 6, 6, 6, 6, 6, write it down 7 times and add it up. Multiplication is just a shortcut for addition. So what is division?
Shortcut for subtraction.
A shortcut for subtraction. Did anyone ever tell you that? See, math is not rocket science. Rocket science is a whole nother field, real complicated stuff. And rocket scientists use math a lot, but math itself is pretty basically straightforward stuff. So what are we going to do? If you're a size 12, we're adding 3. What's your shoe size?
14.
14. If you're a 13-inch foot, what's your shoe size? 17. Follow what's going on? You go, yeah, okay, I follow the math. I just don't like the numbers I'm getting. What? I don't like the answer. Oh, well then, if you don't like the answer, just erase it and change it to make yourself feel warm and fuzzy about it. And what will happen when you turn, no, don't change it, just mark it out and put the one that feels good underneath. Then when you look at the back of the book and check your answer, which one will you find was the correct one? The one you felt warm and fuzzy about, or the one you figured out by doing math? You go, I just figured out why I don't like math. Because when I get my math book and do warm and fuzzy stuff, I miss things. And why does that happen? Depravity. Depravity. It affected your mathematical thinking ability. And we're here in class trying to restore some of that and get it straightened out again. Okay. What do we have next here? Now, if you bought a book from somebody else, it might have said, stop at 39. Well, that was last time. Today, we're going to stop at 43. Say, what's number 41? Use a dictionary to find the definition of deduction and then explain it in your own words. You can do that. 43, briefly describe an instance in which you used induction as a problem-solving strategy to solve a problem. Can you think of a time when you were using induction to solve problems, to solve a problem? Can anybody here think of a time? Look back. We forget so quickly. Look back at page 11. What were problems 11, 12, 13, 14, 15, 16, 17, 18, 19, 20? What's the heading for those problems?
Inductive reasoning.
Thank you. So let's go back to that question. What was the question again? Describe an instance in which you used induction as a problem-solving strategy. And what will you say? To solve problems 11, 13, 15, 17, 19, and 21. Okay? I suppose we should do number 28. Follow this procedure. What's it say to do?
Select a number.
Someone give me a number.
27.
27? Did I hear that? Somebody else give me a number.
3.
3. Someone else give me a number.
5.
5. That's enough. What's 38 say to do? Add 7 to it. So add 7, what do I get? 34, 10, 12. Agreed? What's the next thing I'm supposed to do? Multiply by 3. What does this come out to be? Is that right? You go, I don't know, I think I better bring my calculator to class because I'm getting a headache already. My head is hurting. Well, what's the next thing? What's the next thing I'm supposed to do?
Subtract 6.
Subtract 6. And I end up with And then what? Divide by 3. And I end up with and then what? Subtract 5. Is that right? Uh-oh. Follow the procedure above for 4 different numbers. I only did 3. So I should have put another one up here. Now, represent the original number by n. Oh, what did we get for an answer? The number we started with? Well, that's pretty cool. N. What's 7 plus n? N plus 7. Isn't it, since I don't know what n is? What's times 3? 3 times n plus 7. Everybody follow that? Then what's this down here? Subtract 6. 3 times n plus 7 minus 6. And then divide by 3. Divide all that by 3. And then subtract 5. See what I'm doing? Now, can you solve that? 3 will go into this once, and 3 will go into this 2 times. So now we have n plus 7 minus 2 minus 5 ends up with n. 7 minus 2 minus 5 is n. So whatever number you start with, you're going to end up with the same number unless you make a mistake in computation. Now let's see. I think that's enough. We've pretty well finished topic 1.1. So I can't believe we finished early. But if we did, we did. So, do you have any questions? Do you know what you're supposed to do? Do you know what I mean when I wrote that note on Canvas about show your work? Put your little scratches up there and show me what you're doing. And if you can't, then write out what you were doing in your head to the best of your ability to get your homework done. Yes?
So when we submit our work like online and everything.
What?
So when we submit our homework like online, like email it to you or whatever.
You can do that, or you can bring it to class.
So can we like just like email you the answer and then like bring the scratch paper as proof?
No, if you want to email it, you scan all of your work and send it to me as an email attachment. Yeah. So it's probably just as well to just wait and bring it to class on Wednesday. So you don't have to do all that messy computer work.
Okay.
Any other questions? The people online, they can either scan all their work and email it to me, or if they're close to campus, they can go over to the administration building and give it to the receptionist and ask her to put it in my mailbox. Did you people online hear that? I've got the camera set up so you can see the board, because you don't need to see me. The people online need to be able to see what we're doing. So you folks up there have a good time. You're dismissed. Remember, I'm here for